The Sukhoi SU-27 flanker, interceptor, fighter bomber, and now also a long-range strike aircraft is a truly remarkable aeroplane. Born on the 20th of May 1977 during the Cold War with the Warsaw Pact, very little was known about it in the West until a decade later, when the Russian Reconstruction, or Perestroika, was instituted by Premier Mikhail Gorbachev in 1987. And with glasnost, or openness, the West was in for some shocks, particularly from Soviet military aircraft, which had been assumed to be inferior, especially the Su-27 with its NATO codename of Flanker. This is the remarkable story of a remarkable aircraft and the dedicated team of professionals who, under the supervision of their late founder, Pavel Osipovich Sukhoi, created a masterpiece, the jewel in the Russian crown. After the First World War, Pavel Sukhoi found his fascination with aircraft overwhelming. He graduated from technical school in 1925 and went to work for Tupolev, where he learned his trade. As late as 1927, the Red Air Force felt that it was using too many foreign aircraft. New designs were needed. Tupolev and his chief designer, Pavel Sukhoi, came up with the ANT-5, a single-seater fighter powered by the 460 horsepower M22 engine, giving a top level speed of 160 miles an hour. In June 1937, the first successful polar flight was made by the specially built ANT-25. But that first trip was full of incident when the aircraft had mechanical problems but just managed to limp into Vancouver. The second attempt a month later, on July the 12th, was a different story when Gromov, Danilin and Yumashaev took off from a specially sloped runway and flew 6,306 miles from Moscow to Santa Quinto in California. They'd been airborne for an amazing 2 days, 14 hours and 17 minutes. What's more, they had 3,300 pounds of fuel left in their tanks. They not only broke the world distance record at that time, but the Americans began to realize just how near Moscow was if you flew over the pole. Another long-distance record was set up by an all-female crew flying in the DB-2 Sukhoi long-range bomber. 1939 also saw the birth of the Design Bureau, and it also saw a military aircraft from Sukhoi. It was christened Su-2. It was a short-range bomber powered by the 1,100 horsepower M88 radial engine, and it was used in limited numbers from 1940. But Pavel Sukhoi was an innovator and an experimenter. During the war years, he produced a number of experimental fighters and small bombers. In the jet age, Sukhoi continued to concentrate on fighter bombers and fighters of every description. From December 1949, the Sukhoi OKB was closed by Stalin in retaliation for a failed jet prototype. Sukhoi and his team went back to Tupolev, where they worked on their own projects until Stalin's death on the 5th of March 1953. The first product of the new Sukhoi Bureau was the S-1 prototype of this Su-7, which was originally designed as an air-to-air fighter, but because of the more agile MiG-21, it was changed to a ground attacker. In the spring of 1956, the Su-7 flew at twice the speed of sound for the first time. Sukhoi had also been working on a delta-wing all-weather fighter, the Su-9. Given the code name Fishpot by NATO, the Su-9 was to become one of Sukhoi's great successes. During this time, his aircraft managed to break a number of speed and altitude records. Test pilot Vladimir Ilyushin broke the altitude record by climbing to a staggering 28,852 meters or 86,556 feet. He then got the absolute sustained height record of 21,170 meters or 64,526 feet. Boris Adrianov then broke the world distance record for a fighter by flying 2,092 kilometers, that's over 1,300 miles without refueling. He was followed by Anatoly Kaznyov, who broke the record again by achieving 2,337 kilometers, that's over 1,452 statute miles. Pavel Sukhoi was now seeing the fruits of his labors, as his aircraft were only second down the line from the mighty Mikoyan and its MiGs. The Su-7B became the standard tactical fighter bomber of the Soviet Air Force and was sold to many countries all over the world. The Su-15 Flagon twin-engine fighter interceptor was a development of the Su-9 and 11. The highly successful Su-7 had also been developed further with an uprated Lyulka turbojet and variable geometry wings. It became the Su-17 tactical fighter. At about this time, in 1969, Sukhoi and his team won a design contract for a long-range interceptor that would not only replace existing fighters of the IAPVO, the Soviet Union's air defense force, but also be able to beat the new American F-15 Eagle in air combat. At the time the requirement for the flanker was issued, the IAPVO was equipped with three main fighters: the single-seat Su-15 Flagon, the Yak-28 Brewer, and this enormous twin-seat Tupolev Tu-128, NATO codename Fiddler. This was the world's largest ever operational fighter. It was over 80 feet or 26 meters long. It had a range of around 3,000 miles and a top speed of 1,150 miles an hour. Armament was 4 Ash missiles, which came with both infrared and radar homing seekers. The Su-27 requirement also stipulated that the aircraft would have a limited role with Soviet frontal aviation, the tactical air arm. The Su-27 would be used as a fighter escort for long-range interdictors like the Su-24 Fencer. But at that time, frontal aviation's most numerous fighter and fighter bomber was the MiG-21 Fishbed, which first flew in 1955 and had been designed just after the Korean War. Meanwhile, manufacture of Sukhoi fighters and bombers continued apace. With SAM missiles and interceptors, a strike aircraft was needed to penetrate enemy defenses and fly under radar at very low levels. The Sukhoi OKB failed in their first attempt, but developed the Su-24 Fencer, which, like the American F-111, was a large 2-seat swing-wing strike aircraft designed around the Soviet Union's first integrated avionics system, with a bomb sight, weapons control, and navigation systems coupled to 2 radars, one for attack and one for terrain following. If Sukhoi was to create a fighter better than the F-15, it was obvious that it had to be fly-by-wire to stabilize an unstable design. Unbeknown to the West, Sukhoi had already used a crude fly-by-wire system in his T-4 Mach 3 bomber. One of the problems with the T-4 was that the aircraft flexed a great deal in flight, so conventional hydromechanical controls simply wouldn't have worked. Back in 1967, well before America or the West, the Russians claimed to be the first in the world to have a fly-by-wire system to stabilize the aircraft. Sukhoi had already got 4 years fly-by-wire experience when the Bureau started on their new design, which was eventually to become the Su-27. Vladimir Ilyushin, the son of the famous Russian designer, was chief test pilot for this experimental project. He would also head the flying team for the 27. After the United States Air Force experiences in the Vietnam War, both the Russians and Americans looked at a ground attack aircraft to operate in the heart of battle, but be able to take immense punishment from ground fire and still get its pilot back to fight another day. Sukhoi were the first to protect the pilot with a titanium-armored bathtub. The Americans soon used the same idea in the Fairchild A-10 tank buster, which was more agile but much slower than the Su-25 Frogfoot. The prototype Sturmovik, the T-8, was first flown by Vladimir Ilyushin on the 22nd of February 1975. While Frogfoot was being put through its paces, work was started on the Su-27. The design team was led by Yevgeny Ivanov, with Oleg Samolovich as his deputy. After 2 years of preliminary design work, it's said that the final layout of the aircraft was finalized by just 3 men over a single weekend. Pavel Sukhoi took a close interest in the project, which was to be his last. The hero of the Soviet Union died peacefully in 1975, unaware that his last innovation was to turn the aviation world on its ear and allow the Design Bureau, which still bears his name, to rise to the very summit of the Russian aerospace industry, eclipsing even the mighty MiG. The first prototype flanker, designated T-10-1, was wheeled out of the hangar for its maiden flight on the 20th of May 1977 at Tsukhovsky in the capable hands of its chief test pilot, Vladimir Ilyushin. The aircraft was a typical shape for that era, with twin-tail fins, widely spaced underslung engines, and an integrated wing-to-fuselage. To Western eyes, it was a copy of the F-15. Much later, they were to realize that this could not have been further from the truth. Those early test flights were to show up some serious design faults. It didn't have the range, and there were problems with stability which simply had to be cured. Even with modifications, the design meant that the aircraft was too heavy, had too much drag, and below expected engine thrust. It was clear that a major redesign was needed to get the fighter into shape, and the man given the task after Sukhoi's death in 1975 was Mikhail Petrovich Simonov, who was eventually destined to take overall charge of the Sukhoi Bureau. By today's standards, test facilities were fairly crude, but they had to work. Everything on every aircraft had to be tested to the limit, and that sometimes meant to destruction. For instance, how would a wing tank stand up to the sort of forces that you get at high Mach numbers where vibration could simply split it apart? And how would the mechanical side of the aircraft react to the pilot? How much actual force would he need to feel realism in a fly-by-wire system? How much would the canopy expand and contract at different temperatures, from very hot to freezing cold? Even the undercarriage had to go through rigorous testing in the lab to find out just how reliable it would be, or what improvements, if any, needed doing. Every dial and the electronics that ran them had to be checked and checked again, redesigned and improved if need be. The ejection system had to work. The hood blows first. The armaments all had to go through the same meticulous eye for detail, whether it be cannons or rockets. Another important test was to find out what would happen if one of the engines got hit from behind. How much damage would the aircraft sustain? Testing of the ejection seat was carried out using a rocket sled. This sequence shows trials of the Su-25 two-seat trainer, which uses the same K-36 ejection seat as the Su-27. The production Su-27 supersonic all-weather fighter interceptor was finally rolled out in 1984 with an impressive set of credentials. It had a top speed approaching 2,500 kilometers an hour, that's over 1,500 miles an hour. But it was also highly maneuverable at very slow speeds, as this rare Russian film shows. It could climb up to 19,000 meters, that's over 2 miles high. It had a range of 4,000 kilometers, or over 2,000 miles, and it could stay in the air for about 5 hours, with a maximum weapons load of 8 tons. Between 1986 and 1989, a highly modified version, the P-42, challenged the American F-15 specially stripped Streak Eagle for a number of world records. The P-42 was so clean that with its uprated engines, it had to be tethered to a military vehicle using twin cables and an electronic lock release, as the standard brakes simply couldn't hold it back. The P-42 set a total of no less than 27 new world records. Its rate of climb was 213 meters, or 700 feet per second. The Su-27 had an integral airframe with the wings and fuselage blended together to give it more lift and less drag. With its relatively fuel-efficient Saturn Lyulka turbofans, its aerodynamic airframe and room for more internal fuel, the flanker had exceptional endurance for an aircraft of its type. It had 2 powerful horizontal stabilizers, flaperons, drooped leading edges, and a fly-by-wire system to improve both its performance and maneuverability. The Su-27 was designed to be unstable and run by its computers, but the fly-by-wire system was so efficient that it meant that the pilot controlled the aircraft in exactly the same way as a stable one. The same system controlled the so-called high-lift devices, raising the aircraft's all-important lift-to-drag ratio during a combat maneuver, again being greater at a greater angle of attack. It also made sure that the pilot couldn't overstress the aircraft, whatever he did. This not only protected it from too high angles of attack, but meant that the pilot didn't have to worry about it, which gave him a psychological edge in a war situation. And it also meant that he couldn't get into an unwanted spin or overload the computer system. The fly-by-wire control system had 4 extra channels, so that if any of its components failed, another channel would automatically take over, leaving the pilot free to get on with the job in hand. Victor Churkin was a combat pilot, so what did he think of the flanker?
The Sukhoi SU-27 is very maneuverable, and its minimal radius of turn is quite comparable with that of piston-engined fighters of the World War II. The fighter's good cockpit visibility and small deflections of its control surfaces make possible to pilot it confidently at small altitudes. I always pilot the fighter with pleasure. I find it hard to believe that an aircraft whose weight exceeds 20 tons is so controllable.
Because the Su-27 was designed to land on rough terrain, its engines are protected from any stones or rubble by these simple anti-ingestion protective screens, which work totally automatically during the taxiing, takeoff and landing phases. Its twin engines are set well apart with an integral fire protection system between them. The wide clearances between the fuel tanks and intake ducts stop the risk of any fire spreading. The early versions of the aircraft had their fuel tanks filled with polyurethane foam. This is a dramatic example of a fuel tank filled with foam and shot at by a round of ammunition. The same again, a round of ammunition fired at an unprotected fuel tank. All these protective measures meant that the flanker should survive if it was hit in combat. The engines were designed to be easy to maintain, with jobs like changing the first stage blades of both a compressor and a turbine right on the airfield, without having to send the whole engine to the repair plant. Two search and track systems were coupled to a look-down pulse Doppler radar, an infrared target finder with a laser rangefinder, and a helmet-mounted sight system, which allows the pilot to aim his weapons at the target without turning the aircraft. A navigation system and an automatic flight control system means that the aircraft can take off in bad weather, day or night, with a 200-foot cloud base and 2,500-foot visibility. There are 10 hardpoints under the aircraft for weapons or stores. Early versions carried 4 Archer air-to-air and 6 Alamo missiles. Apart from the underwing stores, Flanker has an internal 30mm cannon with a potent 200 rounds of ammunition. The cannon is linked to the target designator with a rangefinder which is said to help in close combat. With its variety of missiles, the Flanker can fight from a distance or at close quarters. One of its requirements was to escort the Su-24 Fencer bombers to their targets. While the squadrons took off, the Aleutian A-50 AWACS got itself into position to control the battle. The flankers led the bombers towards the target area, guided by the AWACS, and literally blasted away through any enemy attack using their range of missiles. Until the way was clear for the bombers to drop their load. Even by 1987, the West hadn't had a good look at the Su-27. But one of its first encounters turned out to be too close for comfort. A Norwegian P-3 Orion patrol plane met 2 flankers. One of the flankers got too close and hit one of the Orion's props, damaging both aircraft with bits of the prop flying through the Orion's fuselage. Now the West had seen Russia's mystery aircraft, its aviation industries were suddenly spurred into action. 1989, the Paris Air Show was the first time that the Western crowds were to witness for themselves how true the rumors had been about the Su-27. Was it as agile and potent as they'd been led to believe? Test pilot Viktor Pugachev left them in no doubt at all with his dazzling display. He pulled his 22-ton aircraft straight off the runway into a vertical figure of 8 within an 800-meter frame. Pugachev stunned the crowd with a maneuver never seen in the West before. Pugachev's Cobra, a move that he'd invented himself and that was to become an international trademark for the Sukhoi. The aircraft flew straight and level, then pitched its nose up to 120 degrees. Pugachev then pushed the stick forward and into level flight again. No other fighter anywhere could do the Cobra. It seemed that the rumors were true after all. This was indeed a truly remarkable aeroplane. Its chief test pilot, Vladimir Ilyushin, was in no doubt at all.
Before flying this aircraft, I piloted vehicles of 142 different types, and always came to know that I was, so to say, more intelligent than a flying machine, and more capable than it was. In the case with the Sukhoi SU-27, it was the other way around. It appeared to be more intelligent than me. The aircraft is more capable than a pilot. So, in order to use its great potential, a pilot's self-perfection is essential. Moreover, when I piloted the Su-27 for the first time, I understood this was the aircraft you could wait all of your life. It's worth being a pilot of this fighter. On account of a delight I felt in the air, a smile doesn't range from my face till now. I'm sure that everyone who will pilot the fighter will feel the same way.
The Russian Navy had planned to build 4 new aircraft carriers to take them into the 21st century. In fact, only one was completed, but even that needed new aircraft. Sukhoi began by altering its basic Su-27 design by fitting canard foreplanes, an arrestor hook, a beefed-up undercarriage, a refueling probe, and twin nose wheels. Land trials were started at Saki in the Crimea on a dummy landing deck with arrestor wires and a ski ramp for takeoff. It's understood that during these trials, at least one Su-27K was in fact lost. Other changes to the basic 27 were that the distinctive tail cone section was shortened to miss the deck on landing and rotating. There was also the plumbing available to carry an external fuel tank. Trials went on day and night until it was felt safe for Viktor Pugachev to find the aircraft carrier Tbilisi and to land on it for the first time. He refueled in the air and tracked in towards the carrier. Then lined up for his final approach. First time around was a touch and go just to get the feel of the pounding ship. Then a second attempt. Third time lucky. Yes, on the third attempt, he brought the flanker in for a perfect deck landing. Where Mikhail Simonov and the engineers and crew were waiting to give him a hero's welcome. Pugachev's historic landing was made on November the 1st, 1989. His takeoff run proved that the Su-27K could get into the air after a ski run of 100 meters, or 328 feet, with no catapult. It was soon the turn of his heir apparent, the young Yevgeny Frolov, to bring his aircraft in for a perfect landing on the Tbilisi. He got the customary welcome from the waiting crew. Later, the carrier changed its name to the Kuznetsov, and the aircraft uprated to the Su-33. The great rival for the naval contract came from Sukhoi's arch competitor in the form of the MiG-29 KVP. It too had wings that folded for stowage. To get full power before takeoff, the Russians used this very simple chocking system built into the deck. Once the aircraft is at full power, the retaining chocks simply disappear. Although the MiG was an equally fine aircraft, which had been well proven over the years, it was Sukhoi who won the contract to supply its 33s to the Russian Navy. However brilliant an aircraft seems, accidents and failures will happen, as this MiG-29 pilot found out. In the early stages of the flanker's development, the second prototype was lost in a fatal crash. A wing fault killed another pilot and nearly destroyed a second T-10. Fortunately, these two men lived to fly another sortie. To the uninitiated, both the MiG-29 and the Su-27 look very similar, but there are distinct differences. The Sukhoi is a much larger aircraft when you compare them closely. The MiG has a shorter nose and is not as drooped as the Sukhoi. Looking from above and behind, the Sukhoi has a much wider fuselage. The MiG cockpit seems smaller and slightly more cramped than its bigger brother, where there's not only more space, but the Sukhoi seems a lot more complex, and it looks a little more modern. But both look positively ancient compared to the American F-15 layout, with its state-of-the-art screens instead of old-fashioned dials. In fact, the whole Sukhoi program was developed because the F-15 Eagle was far away and ahead of anything the Russians had in the early 70s. Even in the F-15As, which went into service in 1976, the pilot sat high with an excellent all-round view, surrounded by analog instruments, with his head-up display on the windshield in front of him. The first F-15s to engage in combat were blooded by Israel on the 27th of June 1979, when they claimed 5 MiG-21s of the Syrian Air Force. The F-15E is a strike attack aircraft with a top speed of 1,650 miles an hour and a ferry range of 3,570 miles. Farnborough 1990 was the first time we'd seen the two-seater version of the Su-27, the Su-27UB. To all intents and purposes, the two-seater version could do everything that the single-seater could do in the capable hands of our old friend Yevgeny Frolov. takeoff, it has a thrust-to-weight ratio of better than 1:1. That's an awful lot of poke. Frolov threw 22 tons of aircraft around the sky as if it were a small aerobatics plane, with lightning-quick spins and a huge cobra of over 120 degrees. Some argue that this maneuver is merely an airshow stunt. Others argue that in combat the aircraft can be slowed down so quickly that any hostile missile would find it very difficult to hit its target, and an enemy fighter on its tail may well overshoot the SU, just as the Harrier proved with its spectacular Viving maneuver. As Yevgeny got out of the Su-27UB, he was to come face to face with Captain Mal McNair, who had just demonstrated his CF-18 Hornet. The two former enemies were soon into pilot's talk and couldn't wait to have a guided tour around each other's aircraft. Mal was relieved to see that the SU cockpit was relatively old-fashioned, but the Russian policy at the time was to standardize all fighter cockpits so that any Russian pilot could transfer from one type to another with as little interruption as possible. The Hornet, on the other hand, was equipped with the very latest glass cockpit, with most of the pilot's information transmitted on computer screens. So how did the Sukhoi compare with Western fighters? Mal McNair.
I think it compares pretty favorably with Western fighters as far as airshow performances. As far as what it would do as a weapons platform, that hasn't been proven yet, and hopefully won't be proven in the future, but in my personal opinion, not the opinion of my government, I think the Western fighters still hold an edge in the avionics and the weapons systems we have on board.
So how do you do the Cobra? Well, come in level at 220 knots with 85% power, pull back with about 35 pounds of pressure on the stick to override the angle of attack limiter. The aircraft rears up with its underside becoming a huge air brake. Push the stick forward and ease in some power to return straight and level. If you make a mess of it, press the small white button on the top right of the control column, which engages a system that will automatically correct the aircraft, whatever its attitude. The Su-35 was designed as a follow-on from the basic Su-27 with much better dogfighting capabilities, and was the first derivation aircraft to have an unstable integral triplane or three-wing aerodynamic configuration. It has a new glass cockpit with a vastly uprated and completely new digital fly-by-wire control system, which is quadruplex, using 4 channels in pitch and 3 in yaw. It has a totally new radar, allowing 15 targets to be tracked at a time, with 6 that can be engaged at a range of 225 miles. It also has a redesigned tail cone with a reshaped tip housing a dielectric radome rather than the usual brake chute cover, giving it over-the-shoulder radar coverage. The aircraft is capable of automatic terrain following and avoidance, and it can attack ground targets without even entering the battle area. Apart from new uprated engines, the Su-35 has new tail fins, taller than the 27UB, and each one houses an auxiliary fuel tank. Finally, the Su-35 can carry a very long-range anti-AWACS missile to knock out the enemy's combat control system. Yet another derivation of the basic Su-27 is this 27IB Platypus fighter bomber. Anatoly Ivanov climbs up the nose-wheel ladder into the spacious cockpit. The cockpit itself is surrounded by titanium armor some 17 millimeters thick. It's thought that the original concept of the aircraft was as a naval trainer with its side-by-side seating. An altitude pressure of 7,000 feet is maintained in the cockpit up to 30,000 feet, which means the crew don't have to work with their oxygen masks on. The Platypus is equipped with air-to-air refueling, which gives it a very long range, and the crew can even lean back on one of the seats and take a nap on a long endurance flight. The Su-32FN, confusing, isn't it? The Su-32FN is an updated version of the 27IB, with a beefed-up main gear having 2 wheels per side and a double nose wheel. When it arrived at the Paris Air Show in 1995, it had flown non-stop from Moscow with no in-flight refueling at all. Every country has its display teams. The British with the red arrows, the French with their Patrie de France. The Russians are no exception. One of their teams is the Russian Knights. Their leader flies the Su-27UB conversion trainer. The rest of the team fly a mixture of single-seaters and two-seaters. Their show is not as flamboyant as the Reds, but it doesn't need to be, as it's still unique. The pilots are chosen from the 234th Prokhorovsky Guards Fighter Regiment at Kubinka. The Sukhoi SU-27 Aerobatics Demonstration Team, the Russian Knights. The modern Sukhois can carry a variety of weapons, but the basics are still the R-27 Alamo and R-73 Archer. The Archers are the smaller of the two, and they're usually found on the outboard rails. They have thrust vectoring vanes, which make the missiles very agile at short range, of up to, well, a couple of miles. The R-27 Alamos are generally stored on the inboard rails. This is one of the weapons the former Soviet Union is alleged to have stolen from the West. Well, it does have a resemblance to the Sparrow missile. Both missiles are long range. They're both missiles that are launched once a target has been spotted on the aircraft's radar. They also have a small radar of their own for guidance and detonation on the target. Maximum range, it's about 35 miles. Apart from the Alamo and the Archer, the Sukhois use the long-range AAML and very long-range anti-AWACS weapon. The naval Sukhois, the 27K and the Su-33s, carry a centerline KH-41 Mosquito anti-shipping missile and a clutch of long-range weapons, but all missiles are constantly being updated. As Sukhoi progress by bettering a basically superb machine, what are they up against in the 21st century? Dassault has invested heavily in Rafale. June the 8th, 1995, the Dassault 1 single-seater shot down a Mica missile guided by a new radar developed by Dassault. Rafale comes in different sizes, with a two-seater, a single-seater, a naval version, and it should replace half a dozen strike interceptor and reconnaissance types in the French Air Force. Lockheed Boeing won a contract to produce the replacement for the F-15 Eagle, the F-22. It'll cruise long range at supersonic speeds without afterburners. And it uses stealth technology to beat advanced radar defense systems. The contract was won after a contest with McDonnell Douglas. Its problem is, of course, its massive cost. Another aircraft in competition with Sukhoi will be Eurofighter, which progresses as we head towards the millennium. It's a joint venture between Germany, Britain, Italy, and Spain, with each country contributing in the development. In September 1996, DA-2, or Development Aircraft 2, in the capable hands of test pilot John Turner, gave a well-paced performance at Farnborough 96. He was limited in power with two Tornado engines instead of the planned Eurojet 200 engines. But Farnborough was about to witness one of the greatest air displays in its 50-year history, from a Sukhoi, the new Su-27. No other jet fighter in the world can do a 360-degree loop virtually in its own length. The Su-27 can, but how's it done? Well, it's partly down to the vectored thrust. Instead of having jet thrusts pointing directly backwards, the pilot can move the nozzles up or down to give the aircraft extra maneuverability. Test pilot Yevgeny Frolov thinks that the new fly-by-wire system and the new nozzles make a big difference.
Yes, big difference because absolutely new control, absolutely new flight-by-wire. Of course, nozzle control system is new too.
With the new nozzles, Frolov can do a super Cobra, which he can stop at any time and roll out of.
Super Cobra, it's Cobra together with control. In all position I can stop this Cobra. I can make Cobra through 360 degrees.
But does the nozzle control have a separate lever?
Okay, we have a button on the stick. If I not push this button, control is normal. Or if I push this button, I can cross limited angle of attack and G. When I making 360 degrees Cobra, I pushing this button and pull stick.
So can we expect to see this new nozzle technology on any of the other Sukhois in service?
Yes, of course. It's first prototype of plane with nozzle control. Of course, if when we will have good potential of this system, we use on all plane Sukhoi. It's a serial engine and only new nozzle control. This same engine we can set all Sukhoi plane on Sukhoi 27 too.
And perhaps on Eurofighter?
Yes, of course, why not?
John Turner, test pilot for Eurofighter, doesn't think he needs vectored thrust.
Vectored thrust and a large canard that's placed well forward of the main plane, as this aircraft have, are two ways of solving the same problem, and that's getting maneuverability at supersonic speed. If you have a large canard, and you'll notice that none of the other aircraft here have a canard of the same size, nor indeed of the same moment arm, I move sufficiently far forward from the main plane, as we do. If you have that large canard with a large moment arm, you don't actually need to use the nozzles.
During Farnborough Week 1996, the Russians threw down a challenge. Mikhail Semenov said that here at Farnborough we can take on any American pilot and we'd be happy to perform an actual dogfight.
Well, certainly under the right circumstances, you'd like to have that challenge to go up against. It would be an interesting fight.
Needless to say, the challenge didn't take place, and John Turner was not too impressed with the Cobra as a combat maneuver.
The big problem that I have, and most of the combat pilots that I've spoken to feel the same way, is that they're wonderful effects for an air show, but they don't do much for you in combat.
People used to say the same thing about the Harrier, though, didn't they? Wonderful airshow aeroplane, they said, but not much good when you get it out in the real world.
That's true as well. And if you look at the Harrier VIF maneuver, which was, when it was first introduced, thought to be absolutely
wonderful. That was a vectoring in
wonderful.
forward flight.
That's right, where he uses his nozzles just to slow his aircraft down and make it go stationary effectively in the air. Well, I've flown in a Phantom against someone doing that. That was horrifying the first time you saw it. The second time, you just shot him out of the sky because you knew where he was going to be for the next 2 minutes. So it actually makes the combat pilot predictable. And the one thing you don't want to do in a modern combat is to let the enemy know what it is you're going to do next. The Cobra maneuver actually is not a problem for the weapon system that we carry in this aircraft. And indeed, it's not a problem for most weapon systems nowadays.
But surely things never stand still for long in modern aviation. Time for a last look at the breathtaking performance of the Su-27. No one can doubt that Pavel Sukhoi's legacy has been a world shaker. His influence will be with us for generations to come.